Welcome again. We're in the final stretch of the introductory Python course. We have gone through the Head First Python book. Got all the pages we covered. We're like all the way down to the last few here, so it's pretty exciting. And today, what I decided to do is, instead of actually going straight through the code in the chapter, I'm gonna explain some concepts. I think it's more useful for folks watching this video, either as a standalone or as part of the class, and then see how it applies to the code at the end of the chapter. I think that will work better. So let's get into it. So today we're going to talk about decorators, and decorators is a topic that I was looking forward on doing some more learning, so deepening my knowledge on them, and this chapter was great. The first thing we need to understand about decorators before we get into it is that a decorator manages or deals with functions. Decorators themselves are functions. And to understand that, let's review a few concepts regarding functions. We talked at the beginning of the course that functions are objects, right? So objects inherit from their classes. They have methods. They have the arguments, right? There's those variables within them. And as an object, they can be assigned to a variable, right? So you can take an object and reference it through a variable. You can place them inside of a list or a dictionary, right? So for example, let me put this little code here on the bottom. So if you're defining a listing, right, and you have an empty list, and then you go, well, my listing, I'm gonna append. You can append, assuming you define a class, and then you create an object. It's called object one. It could be part of the what's it called, of whatever of the list that you're appending it to, and it will go there. And if you check the type, it's gonna be type an object, and it will tell you from what class is inheriting. So it's pretty interesting. They can be passed as arguments. They can exist inside other functions. In other words, they can be nested. And if that sounds weird to you, don't worry, we'll get in a few examples on that. And since they're inside a function, they can also be returned or pulled out of the function. So these properties of objects that apply to pretty much everything in Python, because everything in Python at the end of the day is an object, are functions also as objects. All these apply to them, okay? So now you're sitting there thinking, so what? What do I care? Well, I'll tell you right now. So I have an example here of a function, and we're gonna call it, we're gonna define it and call it decorator underscore ex. This is for decorator example, right? And notice that it has one argument, and the argument is gonna be a function. That's why I call it func for function. And that goes with the principle that I explained previously, that functions are objects and they can be used as arguments. So here we're applying that. We have a function, and it's going to receive a function as an argument. Inside this function, there's another one that I called wrapper. It has no arguments. And what does wrapper do? Wrapper will print something, right? And then it will take the function that was passed as the argument, and it's gonna call it, make it do whatever it's supposed to do. And then it's gonna do something after that function call. And then it's gonna return this this internal function to the main function, okay? Okay, so bear with me. I know this kind of might confuse you, but bear with me, it'll make sense. Here I have a second function called Python is cool. And the only thing it does is print Python is cool and 3 exclamation marks. That's all it does, okay? So actually, let's do this, so we can start making some sense out of this. I'm gonna comment a couple of these lines. So I'm just gonna execute the Python is cool function. So I'm just gonna call it. So let's see what happens. Python is cool, exactly what we expect. That's fine. Now what we're gonna do is we're gonna take the function called Python is cool, and we're gonna assign to it our decorator example function. And we're gonna use the function Python is cool as an argument to feed into our decorator, okay? And based on the logic I explained, if this works fine, what would happen is the wrapper function is gonna be defined. It's gonna go and wrap around our function. It's gonna print this, call our function, print this, and be done. So we're gonna do that right in a second. Before we do that, I wanna show you that, look, if I do this assignment, if I take Python is cool as an argument, and then I assign it to a variable, this variable, it will tell you that it is an object. So if we do that, it will tell you, look, yeah, it's a function, right? It's a function, object function, and it's coming from the decorator example function, and is returning by a local function called wrapper at this memory address. So you can see here how I can call a function as an argument. How can I assign it, right, to another function, and then that object pass it over, that function to the variable itself, right? Which is pretty neat. Now, you're like, this is super confusing. Now, this is the part that the light will turn on. We made this assignment, right? We take our decorator, feed it the function that we wanna kind of alter, and then we're gonna call that function that we altered. So let's do it. So check this out. It went and said, okay, stop before function is called, executes the function, Python is cool, stop after function is called. So why is this interesting? It's interesting because imagine you have a function here that's super long with a whole bunch of different things that you're doing, and you need to change it. But you don't want to change the function, right? You want to make sure that that function does something before or does something after without you changing the original function. If you need to do that, then you need to use a decorator, okay? Let me explain that one more time. You may have a function that you use across your whole programming parsers all the time, right? And maybe you want to put a conditional here. Well, I want to execute this function if these things happen. If not, then when these other things happen. Instead of having to look for that function, the times it's being used in your code, let's say you call that function 50 times. Instead of having to go 50 times and changing every one of those functions 50 times, just put a decorator on top. There's one line of code, kind of like this, and it will work for you. It will make that change. It will add this print and this print, you know, after your function executes. And to me, it's pretty mind-blowing. We are literally adding more functionality to our function, kind of redundant, but having our function do more without changing it. I did not touch this function. All the new functionality or changes come with the decorator, okay? Now, with that being said, all those words, doing this kind of assignment is kind of clunky, right? Because I gotta keep track of, okay, this is the function I wanna change, Python is cool. I'm gonna take a decorator and I'm gonna pass through that decorator the function that I care about and return it back to itself so we can then show the results after decoration. And that's kind of tough to remember. So what Python does is they have a thing called Syntactic Sugar. And Syntactic Sugar, what it does is it allows us to do a couple of things. Just bear with me for 1 second. All right, so Python provides, like I said, Syntactic Sugar. And what is that? Notice that we have our decorator function here, just as before. It hasn't changed at all. Right? It's the same exact thing. But instead of having to do this assignment, this long assignment here, to apply the decorator, what you do is you take the @ sign and call the decorator function right here. And then whatever function is underneath it will be decorated by the decorator function on the top, okay? And if we go and print our decorated function to see if it's an object or, well, actually, before I do that, let's do the first line first. So if we execute our function, it's gonna be decorated, I keep doing this, it's gonna be decorated as expected. And if we check if it's a function, and it does, it tells you, yes, a function is coming from decorator, and internally it's using wrapper to at this memory address, right? So notice how it's the exact same thing, but this is way easier to kind of wrap your head around when you're decorating stuff, right? You just say at whatever it's up here, that function is our decorator, and then whatever block of code comes underneath it will be decorated by our decorator function. And in this case, it's doing these type of things. Right? Let's do another example. I have here, and let me just look up for the, I think it's here, right? Yeah. All right. So here I have a file that has 3 decorators here. And they're the same decorator, but they just have different changes. So for now, ignore these. Let's focus on the first one here. I have a function called doublet. It's gonna have a function as an argument, and the wrapper, I called it wrapper doublet. You know, use a descriptive name, because what it does is takes the function that's being received as an argument and just executes it twice, and then returns the wrapper. That's all it does. It runs your function twice. That's it, okay? So what I'm doing here is we're gonna go and have another file that's gonna use those decorators. And it's gonna go and say, okay, from decorator examples, which is the script here, import doublet. Import doublet. Does that make sense? So now it's like importing like a module, right? You can have all your decorators in one location, and then you can import them and use them as needed. Okay, so that's what we're doing here. Remember, functions are like objects. We can, you know, move them around, import them, assign them, all that good stuff. So from decorator examples, we're importing doublet, right? And based on our just reading of the decorator, we're gonna do it, decorate it. And the expectation is when we call our function, what should it do? It should what? Call the function twice. Therefore, what should we expect? To see Python is cool, what? 2 times. So let's see if that's true or not. Python is cool. So let's run it. And the decorator works as expected. It calls the function twice. It doubles it. And notice how I'm doing this twice without changing the original functional 1 bit. It's being decorated. That's fantastic. That's just as we have learned. Now, what happens if I want to pass an argument, or my original function needs an argument? For example, I have one here called nameIt, a function called nameIt, and it's gonna print out using an F string, look, whatever name we provide, Python is cool. We're gonna decorate it the same way we did previously, and we're gonna execute it. Let's see what happens. There's an error here, there we go, let's do it again. Like I said, let's see what happens. Oh, look at this. It tells me, oh, okay, there's a problem here. Wrapper doublet, which is the wrapper within the decorator, takes 0 positional arguments, but 1 argument was given. Which one was given? Name. Here, when we called it, I gave it the name Alexis. I provided that argument. And if you go back to our decorator, there is no argument here. That's why it's crapping out. So how can we solve that? Well, what we're gonna do is, we're gonna make sure that our decorator is able to handle an argument. So we're gonna use the variable arg, and then we're gonna execute that function, you know, receiving that argument that we're sending it when we call the function. So we're gonna try it again. Remember, we're sending name over, and name in this case is my name, Alexis. So let's run it. And look, it works just as expected, right? So you can send over arguments and your decorator can deal with them as long as we remember to, you know, put that argument there. Okay, now it's gonna get a little bit more complicated. What happens is I wanna decorate, use 1 decorator for both a function that has an argument and a function that doesn't have an argument, right? How can I make sure that my decorator can call the function twice, in this case, do it twice, when both functions, one needs an argument and one doesn't, right? That's the problem. Let me give you an example. Let me just show you. For example, look at it here. Right. If I go and execute this one, doesn't need an argument, but this one does. So if I leave it as is and I run it, it's gonna crap out because look, it's missing one argument, of course, because there's no argument here and your decorator is expecting one. And if I go and do the opposite, okay, then I'm gonna take that decorator out, that argument out from my decorator, like this one, then what's gonna happen? The first one runs because it's not expecting an argument, but then the second one craps out. So what gives, right? I just need to decorate whatever function to make sure it does what I want with or without arguments. So in order to do that, the trick is using a thing in Python called Args and Quarks. And it's the last line here. What am I doing? 1, 2, 3. I'm missing 1, 2, 3. There we go. So what does it do? So it's gonna be, okay. What it's gonna do is it's gonna say, okay, if I receive any arguments, right, it could be 0 or arguments, right? And here Quarks is keyword arguments. That means if you send like a dictionary that has key value pairs, so 0 or more key value pairs. So if I receive those, right, I'm gonna send them. If it's 0, I send nothing. If there's something, I send whatever I received, right? Args and Quarks. And this is pretty neat because now using Args and Quarks, actually, you know, since I wanted to make it look cleaner for the run, let me just comment this a little bit. Oops. Commenting, there we go. There we go. This is a little bit cleaner. So I'm gonna call the function with no arguments and the function with arguments. And Quarks and Args, pardon, and Quarks, it will say 0 arguments, run it, or if there's any arguments, pass whatever arguments you have. And of course, I need to do something here, is not comment the function. There we go. What I need to comment is this, and I apologize. There we go, that's what I need to comment. Blah, 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 blah. So I got our 2 functions, and here we go. Like I said, and I'm missing one here. Right, so excellent, right? So now our function with no arguments is decorated, and our function with arguments is also decorated. So Args and Quarks, and again, you could write any word you want here. You could put whatever you want, but the convention is that Python developers and programmers use Args and Quarks and use that. So that way I understand what you're trying to do. That would allow you to decorate a function that has arguments or no arguments. It won't matter, it will do it for you. Okay, so pretty neat. Now we can handle both situations. Now, what does this have to do with the chapter? And that's the last part. The code we were working on the example for this chapter was called Simple Web App. Okay. So this is from the chapter, and they wanted to us to understand that we needed to, for example, as we're going to do these different web pages, secure them and check if they're being if the user is logged in. And to do that, we imported session, and this is part of the book, so you can read that at your own leisure if you haven't. We create a session which kind of handles cookies within your browser to create a session, and then from the checker module there, we're gonna import check logged in. And that's exactly what we did in our example. What they're doing here, and I'll show you, is within checker is pretty much, look, a function with a wrapper. In other words, it's a decorator. That's all there is, right? If you're wondering, what is this decoration here, wraps? The book explains that wraps helps you with some troubleshooting. It makes it clear what function are you calling. And again, I'm not gonna go into details here, but it helps you with some of the troubleshooting and keeping track of what function was called within the wrapper, okay? Like this part. Sometimes it gets lost. It only tells you it's coming from the decorator and the wrapper. It doesn't tell you what function inside of it. But wraps helps you kind of keep track of that. All right, and the book will have some explanations on that part. anyways, the important thing is that, yeah, we're importing this decorator, and the decorator, what it does is it takes 0 or more arguments or 0 or more keyword arguments, and it's checked. It checks in session if logged in is part of this session list. And if it is, it will execute the function with arguments or no arguments, with keyword arguments or no keyword arguments. And if you're not logged in, it will return you are not logged in, okay? So what we need to do on this end is simply say, okay, I want to protect page 1, add the decorator, and here's the page 1 content. You want to protect page 2, add the decorator, you're protecting page 2. Want to protect page 3, use a decorator, protect page 3. It will check if you're logged in or not. And this is pretty cool. Notice how for us to protect each web page, it's only one decoration, one line. If you didn't do it that way, you would have to literally copy paste, where is it? Copy paste all this code here, all this stuff for each and every page. And if you have a change in the way you log in, good luck trying to hunt down all the pages you copy pasted this in. Now, if there's a change in how we log in, we can just go to our decorator, like right in here, and make the changes in here, and they will apply to all our functions for the pages that have been decorated, which is, again, super faster, super easy, just one place when you need to make a change, and it applies to everybody. So let's do the actual run and see how that looks. And again, I always forget, what's the command? Anybody remember from last time? I think it's .start server.
I'm trying to remember.
Let's look it up real quick.
Did you remember?
Yeah. And Brooke gave us the command we needed to start our SQL server, so we're good. So let's run this. See if this will let me. If I could just get Safari to open. There we go. Okay. So 127, blah, blah, blah. The first thing we're gonna do is we're gonna log in. So let's log in. And when we log in, oh, I can't connect to the server. What's happening? Oh, of course, we need to actually start the server. I'm sorry, the script. Okay, now we're good. Like I was saying, let's log in and see what happens. Oh, so it says, hey, you're now logged in. Excellent. And to look at that, how it looks on the code, let's look at it real quick. What we're doing is we're going to the login portion. And what it does is, okay, go and logged in is going to be true, right? So we're going to be logged in our session. Excellent. Excellent, excellent. Now, let's go to the decorated, let's go decorated page 2. We're logged in. So in theory, we should get, this is page 2, which we do. And let's look at that piece of code. We went to page 2, as you can see here, is decorated. It does the check. And since we're logged in, it returns, this is page 2. Now let's log off. And again, based on the script, we're gonna now log off. I wrote it wrong. Let's look at the code so we can know what actual, log out, sorry. Log out. We're gonna hit log out so we can log off. Log out. You are now logged out. Perfect. Again, just what we'd expect from the code that we studied in the chapter, right? So what it does is it executes the function, goes to session and pops logged in. It takes it out of the list. So now we are logged out. Perfect. Now, what happens if you go to page 2 again? Based on the decorator, it's gonna check if we're logged in. And like I explained a second ago, it's gonna see if logged in is in session. If it's not in session, it's gonna tell me you are not logged in. So let's confirm that. Let's go now to page 2. Page 2. You are not logged in. So this worked exactly as we'd expected. So to summarize, decorators are a pretty neat functionality of Python. It allows you to take a function and change it and give it, or even take away some functionality without altering the function itself, right? the decorator, the wrapper around it, will do it for you. Functions are objects, and with objects, they have a lot of flexibility in regards to what you might want to do with them, okay? And with that ends chapter 10, talking about decorators, right? Any questions, comments?
I don't see any questions or comments. This is really cool.
Yeah, no, and I'll be straight with the class and everybody. This is not like a super forensic-y thing. I mean, could we have some forensic application to this? If you're a forensic developer, sure. But it's not like a day-to-day thing you're gonna use. But, you know, we start things, we end things, and, you know, we're gonna cover the book all the way to the end as we started. We're gonna finish it. So I want to show you this, but no, I mean, it does have some utility. If you're working on a script that parses something and you wanna, let's say there's a new version of the data source that you have, well, maybe you want to just add that functionality as a decorator and you don't have to mess with your main function as much. So that might be a functionality, but for most examiners, that might not be an issue. But you know that decorators exist and now you know what they do, all right? So thank you so much. And again, we'll see you next class.